We live in a world where urbanisation, industrialisation and the continuing quest for improved living standards fuels economic growth. Raw materials provide the essential building blocks required to enable the growth of the world's most rapidly expanding economies. In a world of finite resources, recycling is an increasingly important component in the supply of commodities. Zincox Resources plc is at the forefront of advances in the recycling of zinc and iron.
Our ambition is simply to become the largest zinc recycling company in the world. And we believe we can do this because we're using a breakthrough technology. And it's a breakthrough not only economically, but also environmentally. And that's rather unusual because generally speaking, if you have something that's an environmental breakthrough, it costs you more. That's not the case here. The technology has now been demonstrated in South Korea, where our plant has a design capacity of 200,000 tonnes of dust a year. That produces about 80,000 tonnes of zinc concentrate and 90,000 tonnes of iron product. This is a flagship demonstration of the technology, which we intend to roll out around the world over the next few years.
Zincox is a British company quoted on the AIM market of the London Stock Exchange. With a head office in the UK, research and development is carried out from its laboratory and technical office in Belgium.
The company was originally set up to bring to account unconventional zinc ore deposits. But some years ago, we recognised the huge potential of electric arc furnace dust, which is a waste created by the recycling of steel. And over the last 5 years, we've completely shifted the company from mining with a little recycling to 100% recycling, and that's what we're focused on now.
The world consumes about 12 million tonnes of zinc a year, of which about half goes into galvanising, a process by which steel is protected by a thin layer of zinc. Currently, when a steel product reaches the end of its life, it's scrapped and remelted in an electric arc furnace. The zinc in the galvanised scrap is concentrated in a dust that's drawn off in the furnace gases and collected in filters. The electric arc furnace dust, or EAFD, is either sent to landfill or partly recycled. This less efficient technology generates problematic waste and has always required a subsidy from the steel industry to be economically viable. There are over 6 million tonnes of this electric arc furnace dust produced annually around the world, containing about 22% zinc, a concentration 4 to 5 times richer than the average zinc mine.
Electric arc furnace dust was an obvious target for us because it's very high grade and there's lots of it. So we set the technical team the target of finding a way of getting the zinc out that, unlike our competitors, didn't need a subsidy.
We review all the existing technology, but none were able to provide the breakthrough in cost we needed. The rotary hard furnace showed great promises, but previous attempts failed. We went back to basics and redesigned every aspect of the process through extensive laboratory test work, pilot runs, and computer simulation. The result is the game-changing process we have developed in Korea. The process we have designed can be broken down in a number of single stages, each of which use well-established chemical processes and standard industrial equipment.
Korea was an obvious place to start the operation. It's got a very large recycling business, the second largest scrap importer in the world, and as a result is generating lots of dust. And all of that dust was going to landfill. We have 10-year supply agreements with the Korean steel mills, which generate about 400,000 tonnes of dust a year. The dust runs at about 23% zinc, which, when we're at full capacity, will generate about 90,000 tonnes a year of zinc in concentrate. This is the equivalent of a medium-sized zinc mine.
In parallel with these 10-year supply agreements, Korea Zinc, one of the world's largest zinc metal producers, has agreed to purchase the zinc product for 10 years.
Our plan was to build a single facility in 2 equal phases. The first phase of the development has cost about $110 million and was financed through Zincox's own equity for about $60 million and $50 million which we borrowed from Korea Zinc using a 10-year off-take loan agreement. We made the original decision to make Korea our first project in August of 2010. We then completed a feasibility by October of the same year, and we had our groundbreaking in March of 2011. The development schedule for the project was very much a fast track. In Korean they say ballet ballet, to keep things moving quickly. About 12 months later then we completed the construction on site according to the original schedule and according to the original budget.
The dust arrives in sealed bulk trailers from all over Korea. is sampled and then assigned to one of 3 silos depending on the grade of zinc contained.
The protection of the environment has been at the forefront of the design of this plant. For example, when the trucks unload, they do so pneumatically, so there's no opportunity for fugitive emissions. This is the floor where we mix the dust, the coal and the binder. So these are the mixing vessels here, and then behind me, on this side, this is where we make the binder. So it comes in dry, we make it up into a liquid like paste, and then that's added into the mixers. That dust on that slow-moving conveyor is regulating the flow down into this briquetting machine. So as you can see, these are the pockets which work together to create the briquettes. Basically, they're all good quality briquettes or large fragments, all of which are fine in the process. And in fact, there's one final screening before they go into the rotary hearth furnace itself.
The rotary hearth furnace is a circular tunnel with fixed walls and roof, and a rotating floor or hearth. It's built on trestles and effectively acts as a very high-temperature circular conveyor belt. The dried briquettes are evenly fed across the hearth, which carries them around the furnace at a temperature of around 1200 degrees centigrade. While in the furnace, the zinc and other volatile elements are driven off. Near the end of a full rotation, the briquettes encounter a large auger screw that sits just above the hearth and discharges them to a chute at the outer edge.
Before we put the briquettes into the furnace, they look like this. By the time they've gone through the furnace, they come out looking like that. They've lost their zinc, lead and oxygen, and they're about 60% of the former size. In addition to the removal of zinc, when the briquettes go through the process, they also metallize the iron, so it becomes metallic iron. So while the original briquette is barely magnetic, after they've gone through the process, the briquettes are highly magnetic.
To stabilise the iron in these sponge-like briquettes, about 40 of them are taken at 700 degrees centigrade and pushed into larger briquettes that are dense, hard and easy to handle. This is the secondary product from the plant and means there's no waste. On the other side of the furnace to the feeder, there is an outlet through which the gases and fine particles of zinc oxide are drawn off. These off gases pass through sophisticated heat exchangers to cool the gas and heat fresh air, which is then used in the process. The off gas is further cooled in a quencher before entering the baghouse, where the main zinc oxide product is recovered.
The baghouse contains 6,000 sock-like filters, which, if put end to end, would stretch 15 kilometres. These filters are automatically cleaned, releasing our principal product, zinc oxide concentrate, which is a white powder running about 58% zinc.
The zinc product is conveyed in a sealed system to storage silos ahead of transportation in bulk carriers. For the first phase of development, all the zinc will be sold to Korea Zinc, whose main smelter is located just 60 kilometres away.
The Korean recycling plant is a 2-phase development. The first phase has been completed and the engineering for the second phase is well underway.
Phase 2 is the mirror image of the phase 1. That's why the phase 2 is already designed. All the major infrastructure has already been installed.
Phase 2 will cost $100 million, and we intend to finance this through a combination of offtake finance and bank debt.
Zincox is increasingly being recognised by the city, and the project recently was shortlisted for the Financial Times and International Finance Corporation's Sustainable Investment of the Year award. Top-rated green tech analyst Andrew Shepherd-Barron at Peel Hunt has been tracking the company's progress.
The point is that Zincox has demonstrated a breakthrough technology, one that should generate good returns. Once they've ramped up production and demonstrated how profitable it is, they've got a business model that can be replicated anywhere else in the world.
Our short-term objectives are not limited to Korea. We plan to roll this out around the world, and we've already done a lot of work in Thailand, in Turkey and the United States, where we've already identified sites. Our plan is to roll this out in a cookie-cutter way, so it'll be exactly the same size, same engineering, same procurement, and that should allow us a very much more accelerated development of these projects. This is a very exciting time for the company. We have a breakthrough technology and a very strong first mover advantage. We intend to press home that advantage as hard as possible so as to create the greatest value for shareholders in the shortest possible time.